Hello class, in this video we will learn about the universal gas equation and how to apply it when performing calculations. The universal gas equation was derived by combining all of the gas laws and is formulated as PV equals nRT. In this equation, P refers to pressure, which must be expressed in kilopascals, V is the volume of the ideal gas, which needs to be measured in liters, N represents the number of moles, R is a universal gas constant, and T is temperature, which must be measured in Kelvin. The universal gas constant, also known as the molar gas constant, has a value of 8.31, and this value is also found on the VCAR data booklet as shown down below. We use the universal gas equation when we're trying to calculate the value for one particular variable when all the other three variables are known. Let's have a look at a couple of examples. In the first example, we're trying to find the volume in liters occupied by 2.24 moles of oxygen gas when the pressure is 200 kilopascals at 50 degrees Celsius. The first thing that we should always do is to inspect each of the known variables given to us and check whether they're expressed in the correct respective units. In this question, we need to convert degrees Celsius to Kelvin, so we're going to add 273 to 50, giving us a value equal to 323 Kelvin. From here, we could use the formula PV equals nRT and rearrange the formula to solve for V. To transpose and solve for V, we need to divide both sides by P, hence the equation should now look like this. From here, we plug in the values into the equation, and crunching these numbers into the calculator should give us a value equal to 30.1 liters. Let's have a look at another example. In this second example, we need to find the total amount of gas in a 10 liter vessel at a pressure of 730 millimeters of mercury and at a temperature of 27 degrees Celsius. Like with the other question, we should always inspect the known values given to us and convert the values when appropriate to the correct units. In this question, pressure and temperature are not in the correct units. In order for us to use the formula PV equals nRT, pressure needs to be expressed in kilopascals. This can be done by converting millimeters of mercury into atmospheric pressure by dividing by 760 and then multiplying this answer by 101.325, giving us an answer of 97.3 kilopascals. Then, we need to convert temperature from degrees Celsius to Kelvin by adding 273, which gives us an answer of 300 Kelvin. Now we're ready to use the formula PV equals nRT to solve for N. This can be completed by dividing both sides by RT, and putting these numbers into the calculator will give us a final answer equal to 0.390 moles. I've got a total of 4 questions in this video that I'd like you to answer to check with your understanding. In this question, calculate the volume of gas in liters by 1.3 times 10 to the power of negative 3 grams of helium gas at a pressure of 60 kilopascals and a temperature of negative 50 degrees Celsius. Pause the video now and resume the video again when you're ready to review your answer. In this question, they've given us the mass of helium gas, so we're going to need to calculate the number of moles by dividing it by its molar mass. Hence, the number of moles of helium is equal to 0.000325 moles. Temperature needs to be converted into Kelvin, which can be obtained by adding 273, giving us an answer of 223 Kelvin. From here, we need to rearrange the equation to solve for V, which can be found by dividing both sides by P. When we substitute the values into the calculator, you should obtain an answer equal to 0.010 liters. Have a go with the next question. Calculate the molar volume of oxygen gas at 1.0 atmospheric pressure and 100 degrees Celsius. We define the molar volume as the volume of gas occupied by 1 mole of substance at a certain pressure and temperature. Therefore, the value of N in this question should be equal to 1. In this question, we need to convert both pressure and temperature to the appropriate units. Atmospheric pressure can be converted into kilopascals by multiplying by 101.325, and temperature can be expressed in Kelvin by adding 100 with 273. From here, we need to rearrange the formula to solve for V, which can be done by dividing both sides by P. Inserting these numbers into the calculator will give us an answer equal to 30.6 liters, which corresponds to option A. Have a go with the third question. Pause the video now and then resume again once you're ready to compare your answer. To use the formula PV equals nRT, we're going to need to express pressure and temperature to the appropriate units. To convert 10.2 atmospheric pressure into kilopascals, we're going to multiply it by 101.325, giving this as our answer. In Kelvin, 25 degrees Celsius is equivalent to 298 Kelvin. Now that we know the values for 3 variables, we can now use the formula PV equals nRT and rearrange the formula to solve for N by dividing both sides by RT. Plugging these values into the calculator should give you an answer equal to 2.36 moles, which corresponds to option C. And in the last question, I would like you to calculate the concentration of oxygen in the container given the following information. Pause the video now and then resume again when you're ready to compare your answer. In this question, they've provided me the values of 3 variables. They've given me the volume, the temperature, as well as the pressure. Using this information, what I'm going to do is I'm going to calculate the value of N, the number of moles of oxygen, by using the PV equals nRT and rearranging it to solve for N. Plugging in these values should therefore give me an answer of 0.00824 moles of oxygen. However, since the question wants us to calculate the concentration of oxygen, what we could do is we could find this out by dividing the number of moles with the volume, and this will give me an answer of 0.0082, therefore corresponding to option D. By now, I'm hoping that you're a lot more confident at applying the universal gas equation when you're performing your calculations. Thank you for watching this video, and I hope to see you guys again in the next one. Bye.